Hello everyone, this is James Shore with Let's Code Test-Driven JavaScript. You're watching The Lab, which is where we explore, experiment, and generally mess about. And today in The Lab, we're doing something I'm really looking forward to. We're going to take an existing piece of code that somebody else wrote, some legacy code that doesn't have any tests at all, and we're going to retrofit tests onto it. This is something that nearly everybody has to deal with at some point in their career. It's not obvious how to do it. Just knowing how to do test-driven development isn't going to help you that much when it comes to adding tests to existing code. So I'm really looking forward to it. So thanks for joining me and welcome to the lab. Let's get started. We are working on, in this episode, we are going to work on intro.js. This is an application that, well, it's a tool, I should say, that provides introductions for websites. So what we can do is if we click this button, you'll see that it highlights part of the page and gives you a description and allows you to flip back and forth between different parts of the website or different parts of the page. So this is the application that we're going to be dealing with. It is a pretty popular one. And it was recommended by Danny Jones. So thank you very much for that recommendation, Danny. And it's got 6,500 stars and 840 forks on GitHub. So this is what we're going to take a look at here. Now, I have already forked this code and downloaded it, but I haven't done anything else. Here is the code right here in WebStorm. And this is the code that makes it all work. So what we have is 940 lines, sort of all put together, reasonably well commented, actually quite well commented. So it's not terrible code, but there are no tests. So our task, our challenge is going to be to put tests around it. And this is going to be a pretty big project. When you're adding tests to existing code, it's not as easy and often not as fun as regular test-driven development, which is why it's good to start doing TDD from the beginning. The reason this is challenging is because most legacy code is not designed for testability whatsoever. So in order to add tests to it, we have this chicken and egg problem. We have to refactor the code to make it possible to test the code. But in order to refactor the code safely, we need to be able to test it. So, how do you get around that? And the trick is to put pinning tests around the code. And I put this in a blog entry, which you can find here. But basically, what you do is you put some sort of low quality tests around your code so that you can have some automation and do your work quickly. Refactor, and then as you refactor, you start adding high quality unit tests and focused integration tests. And when that work is done, you take away the pinning tests. The trick is doing this in small enough pieces that you don't get left with really low quality tests around your code forever. We're going to take this in several steps. First, we're going to review the code and reverse engineer the design of the code. So we're going to figure out how this code is designed at a high level and figure out how it's all put together. Then we'll decide which piece of it we want to focus on. It's important when you're dealing with legacy code, which will often be much bigger than this. This is only 1,000 lines of code. Most of the time you'll be dealing with much larger projects. But even with a 1,000-line program, this is too much for us to do in fairly short episodes. So we're going to choose some subset of this to focus on, and then we're going to figure out how to test it. We're going to figure out how to put pinning tests around it. That may mean manual or automated tests that are end-to-end running against the user interface. If we're lucky, though, we'll find a simpler way to get pinning tests around it that won't be so complicated. So we'll figure that out. Then we'll get the code running. We'll actually get the ability to build and run it locally. And we will set up a minimal bit of build automation, and then we will get our automated pinning test running. And then in the next part, as I said, we'll use that pinning test to allow us to refactor this code and add unit tests. This is a huge amount of work, so I'm going to be releasing this in multiple parts. The first part is going to be focused on our strategy and reverse engineering the code. The second part will be looking at getting our code under control and getting those pinning tests in place. And the third and perhaps fourth, I haven't recorded that far yet, is going to be on refactoring the code and getting automated tests around it and making whatever changes what we want to make to intro.js. I am really looking forward to this. This is going to be a great episode. Thanks for joining me. Let's go ahead and get started. So the first thing I want to do is review the code and reverse engineer the high level design. I call this reflective design, where we look at some existing code and figure out how it's put together. And this is a bit of an art. In a large project especially, you can't go through absolutely everything. What you need to do is be able to quickly figure out what the important pieces are. And when I work with teams, of course, I just ask them, what are the important pieces of your application? But failing that, a good trick is to look for what's big. So if we just scan through this, if this was in multiple files, which it's not, but if we are in a larger system with multiple files, what I do is I'd list out the directories and find out which files were the biggest and start there. In this case, since we don't have more than one file, what I'm going to do is I'm going to scan through this and look for what are the parts of the system that have the longest lines of most lines of code. So let's just scan through this real quick. We've got an intro.js main class. Let me go ahead and start a Scratchpad. Normally I would do this on paper, but you guys couldn't see that, so I'll do it in a todo.txt. So what we have is an intro.js class, assuming that the comments are accurate, which actually you can't always assume that when you're looking at code, existing code. Got this intro for element looks important. Let's add that. Okay. You'll notice that I'm not spending a lot of time looking at the comments, and that's because comments lie. They just lie. People forget to update them. The comments can be helpful to sort of give you a hint, but generally I ignore them. Let's see. Previous step, next step, exit intro. Place tooltip, set helper layer position, show element. Oh, here's another big one. This one's doing a lot of work. Okay, what's next? Get prop val, get wind size, element and viewport, add overlay layer, get offset, and then merge options. No, that's nothing big. Okay, and now we have just... Okay, so this code is pretty well designed. Now, it's really, really tempting. It's really tempting when you are looking at code that somebody else wrote, legacy code, especially if you've been, it's your job to work on it, but you don't really want to. It's really tempting to look at code that somebody else wrote and say, this is crap. Really, really try not to let yourself do that. Every code was, every project was created with some design in mind, and your job as a spelunker into this code is to figure out what that design was. And sometimes, especially in larger projects that have, gone through several developers, that original beautiful design may be crusted over with a lot of crap. But there is still a beautiful design in there somewhere. Your job is to figure out what that organizing principle was, how it all fit together, and figure out whether or not it's still appropriate. But even if it's no longer appropriate, have respect for the people and the design that preceded you, because even the worst code has some stuff in it that makes sense. It's way too easy as a programmer coming into a new project to just look at stuff and say, oh my God, it's word soup. I can't understand this. It's all crap, rewrite. That is a terrible idea. Rewrites mean that you are going to spend a huge amount of time just reproducing what's already been done before. And if you can figure out how to get existing code under control and start refactoring it and get tests around it, you will get done much faster and much more cost effectively. It does take some humility and some willingness to go looking for beauty. Rather than just assuming something's ugly, you have to search for the beauty. Respect the code. That's the key. And as somebody, who has had my share of arrogance and also has been stuck with a lot of legacy code, I know this doesn't come naturally. So that's why I'm spending so much time talking about this. There is no way for you to be successful, to really, really succeed, if you can't find a way to respect the code that's been written before you. Otherwise you'll just spend all of your time hating it and hating your life and wishing you could do something else. So don't do that. All right, off the soapbox. So we've got a couple of things here. We have an intro.js class. We have intro for element. Now the next thing I'll do when I find, the big pieces of code, I will typically just sort of scan through all the other classes or packages if you've got multiple folders of stuff and just try to figure out what the broad pieces are. So let's go ahead and do that. So we've got intro for element, which is pretty large, as I said before. There's a clone object. It says it makes a copy of the object. So we'll call that a utility function. That doesn't look very interesting. Go to step. This looks like a useful function, for lack of a better term, but it's small. So that's interesting. This is just a function that turns around and calls another function. Let's see. Next step. Previous step. That's also quite small. So maybe these aren't just useful function, these are control functions. I'm assuming that the function names are accurate. That's not always a fair assumption. Let's see, we've got exit intro, and that's a bit large. Place tooltip, also a bit large. Place tooltip, this sounds like an internal function to me. This sounds like something that is used within the system, within intro.js, to make the tooltip show up. Remember, when we actually run this, I believe this is what they mean by a tooltip. Although I don't actually know that for sure. I have not studied this code prior to now because I want you to see the actual process of reverse engineering the legacy code. Okay, we've got set helper layer position. That sounds like another internal function that makes this all work. We've got show element, which is our big one. I'd be willing to bet that go to step, next step, previous step use show element. We'll skip past all this. A lot of stuff going on there. Get prop val, that sounds like another utility function. Now again, if in a larger project, I'm not going to do this for every single file. What I'll do is I'll instead look for classes and basically do the same thing we're doing here, is try to figure out how the classes break down. So imagine this at one step up in complexity if this was a larger project. So we'd be looking for files, not functions. And then for the large ones, the large files, we would delve in and try to figure out what their organizing principle was. Okay, so we've got get prop value, get when size. That sounds like another utility function. And element in viewport. That sounds like another utility function. Add overlay layer. I'm guessing that add overlay layer is what creates this grayed out effect with the highlighting. So let's put that under internal function. And by the way, these headers, I just made them up for this project. I don't have anything that I typically follow. Internal function is really not a great term here, but it's basically like a utility function except specific to the purposes of an intro.js. I don't have a better name for it. Okay, get offset. I don't know what that means off the top of my head. So let's look at the comment. It says it gets an element position on the page. Okay, so this is pretty straightforward. Let's call that a utility function. It's very similar to the type of stuff we're doing on the live channel with WeWikiPaint when we try to figure out the relative position of a mouse click. Merge options looks like another utility function. Yeah, it just combines a couple of objects. And then here we have intro.js. This is the constructor. So this is module stuff. So this is var intro.js and intro.js.version And oh, here we have a prototype being set up. That's interesting. That's what converts all these internals to the actual external API. That's kind of important to know, I think. And then we export it. And then right here at the top, we've got some weird factory stuff. This basically makes it work on CommonJS, AMD, or in no module system at all. And again, I think we can just ignore that for now. But one thing to notice here is that all of this is inside of a closure. We are passing in this factory function to the module stuff, puts it all inside of a closure, which is good design for what he's doing, but really terrible for our purposes. Because what it means is that there's absolutely no way for us to call any of these functions if they aren't exposed right here. So that is going to make our life a lot more difficult when it comes to starting to refactor this, because it is all really tightly packaged up. So yeah, all right. So that's right here at the top. I'm not going to make a note of that. I think I can remember that. Okay, so here we have it. We've got intro for element and show element, and then a bunch of control functions and some internal functions. Let's just write down what the API is as well. And actually, let's put that at the top. The intro.js class, it looks like we're only exporting the one class. And I could look at the intro.js documentation, but documents lie. They lie. So we won't do that. We'll just look right at the code. We can look at, I will look at documents to sort of give me a sense of things, but I don't trust it. I'd rather just look at the code. It's more likely to be up to date. So we got clone, set option, set options, start, go to step, next step, previous step, exit, refresh, on before change, and on change. Oh, on after change, on complete, and on exit. Now, one thing I notice here looking at this is that the API actually isn't just deferring to internal functions, which is different than the way I would do it typically. The other thing I notice is that this on stuff sets private variables, and there's no other way to know that what those private variables mean. No, I take that back. Actually, most of this is just calling internal functions. Okay, that's good. And using .call to pass through the this value. That's a little different than the way I would have done it, but again, it's completely valid. You'll often see when working with legacy code that the previous authors chose to do things in a different style than you. You got to let that go. If you're the kind of person who gets really upset about style issues, I tell you now, let it go. You will spend all kinds of pain if you obsess over people having a different style than you. So the braces are going to be in a different spot. The parentheses are going to be done differently, or even inconsistently. So just let it go. Style doesn't matter. You can still read it. Well, it doesn't matter that much. I had a project I worked on once where there were only 4 developers. There was me, I was the lead, and there were 3 other developers, and they would not agree on style. So eventually we just got together and I said, okay, this is ridiculous. Use whatever style you want. And if you're in some code, just follow whatever's in that particular file. And of course, we ended up with 3 different styles out of 4 developers. We also agreed, though, that we're going to do code reviews because this was before XP and pair programming. We agreed we're going to do code reviews and we were going to have really good comments and we were going to have certain design styles like not passing nulls that we were going to follow really religiously and enforce in the code reviews. And you know what? The style, like the brace positions and stuff, which was quite different across all these different files, didn't matter. The code was actually really good code for its time. What mattered was that we were caring about the design stuff. So yeah, let go of your style prejudices. It is essential to be successful with legacy code. All right. Well, as legacy code goes, I've seen much much, much worse. I kind of wish this code was worse so we could have more fun with it. But it's still going to be a good challenge. So what do we have now? Let's take a look at this API some more. It's pretty much just calling obvious things. One thing that's not obvious is that start leads to intro for object, and go to step, next step, previous step, do the obvious thing. Exit goes to exit intro, and refresh calls set helper layer position. Interesting. Yeah. Okay. All right. I feel like I'm starting to get a sense of this. Go to step, next step, previous step, and exit intro are sort of the way we get into this. But I'm guessing that intro for element is what gets this all set up, and show element is what makes it jump from element to element. The way we know that for sure is let's take a look at next step and previous step and see if I'm right. If I'm right, it's going to say something like show element.call. Yeah. Yeah, it's just doing a little bit of setup to say what the next step is going to be, and then it calls show element. I bet your previous step does the exact same thing. Bam. Yeah, there it is. Okay. So yeah, show element is what's doing the heavy lifting for displaying the intro. And what does intro for element do? I'm guessing that sets up a bunch of our variables. Start is calling, start's calling intro for element. So if we go there, here we are. Yeah, this is a bunch of option stuff. This is, again, it's pulling something about data annotations. I'll bet you it's pulling stuff out of the DOM. Yeah. Yeah, removing null elements, sorting items. Yeah, that is just setting things up, adding some event listeners. Yeah. I wonder if this one ever calls show element. No, it doesn't. In fact, the only things calling show element are next step, previous step, and that's it. That's actually a really good design. If you find that a key thing like show element is only being called from a few places, that means that you've got a pretty clean design, so that's nice. Now the question is if intro for element doesn't call next step, how does this thing get going? Well, maybe start. Yeah, that's an interesting question, but I don't think we need to know the answer to it right now. Okay, so this is initialize data from DOM, or initialize the steps from the DOM, or config. Okay. That's enough, I think, for us to get a pretty good first idea of how this works. Again, when you're reverse engineering existing code, you're not going to spend a lot of time delving into all the details of the code. You just don't have time. I've already taken about half an hour on this piece, so you obviously have to go through it very quickly, make some rough generalizations and some educated guesses, and be willing to change your understanding as you go. And typically when I'm doing this, I will write down the file names on a piece of paper with an idea of what I think they are, more or less like I've done here. And then I'll throw that away because after I've lived with the code for a little bit, I just have it sort of intuitively in my head about how it all fits together. But yeah, I think what we have here is intro for element sets us up, show element does all the work, and then these just change a few bits of private data and then call show element. And I'm guessing that these internal functions probably are used by these two. And these utility functions, these are just, standard stuff. We don't need to worry about them. And same for the module stuff. Okay, so that is the end of the first part when you're dealing with legacy code, is First, just get a rough understanding of what the design is. And remember, search for the beauty in the design. Look for what makes it work and what the original authors intended, even though it's probably gotten crufted over time by other people who don't really understand the design or who are just in a hurry to get something in. That original pretty design, that original conception has probably gotten lost in a lot of ways. But don't let that turn into hate for the design, because as Yoda says, that way leads to the dark side of the Force. You just won't be happy if you can't love the code you're working with. So every code has something good about it. Look for that good thing. Okay, next thing, we're going to decide what we want to change. Now, typically, when you're dealing with legacy code, what you're going to do is you are going to have some reason to touch it. You're going to want to add tests to it because you're working in it and you're finding problems. So we're going to be a little artificial in this case. We don't actually have any changes we want to make. Actually making a real change to intro.js is probably beyond the amount of time we have here. Although I do notice that there's kind of this annoying jump when you go from step to step if the next step doesn't show on the page. So it'd be nice to have it smoothly scroll down rather than jumping down like that. Maybe that's something that we can consider. In order to do that, I'm guessing we'd want to change show element. And show element is definitely the biggest, ugliest function in this class. Although it's not terribly ugly, it's definitely right at the center of how this all works. So let's take a quick look at show step again, or is it show element? Yeah, show element. Is this as interesting as I think it is? It's doing a lot of classes, it's creating elements. It's setting up event handlers. Oh yeah. Yeah, there's a lot of stuff going on here. Placing the tooltip. Yeah. Checks to see if it's, so here's the code right here that would allow us to scroll. Interesting. So this is what we would change. Yeah, it is definitely better when you're adding tests to legacy code to be focused. If we just said that our charter, our purpose here, was to add tests to the entire code base, then we would be writing tests forever. But if we can really restrict our charter to doing just one thing, what that means is that our pinning tests can be smaller because we're going to be dealing with less code. And also the changes we have to make are going to be smaller too. So maybe what we want to do is test this. But looking at this code, I don't like how big it is. I would love to factor this whole thing apart. And if this was a real project, I probably would want to start factoring apart show element and breaking it apart, because it's not enough to just fix one small thing. Especially in legacy code, there's often knock-on effects where you change one thing and something else in an entirely different part of the system breaks because it changes a global variable or something else that you don't recognize. So it is good to get more control over it. So let's say that our charter is to refactor show element and to add smooth scrolling to step changes. And we may not get to that second one. Okay, so if that is our goal, if we're going to refactor show element, then step 3 here is to figure out how to test it. Now remember, to get started, we're just starting out with pinning tests. We want to get a basic test around this function and enough of the code to allow us to refactor this safely. So how do we do that? Let me take a look at this. Okay. There is a lot going on here. There's a lot of classes being changed. There's some timing. In other words, this only takes place after the animation has finished. There is some element creation and class assignation and event handlers and DOM manipulation. Lot going on here. This is where depression starts to sit in. Yeah, I think what we want to do, I mean, what I'm thinking is that at first I was like, well, we could just write some karma tests that verify that just the things we care about change. But the deal with legacy code is you can't predict everything that's going to change. I mean, often, in all honesty, you will typically find that you think you know how the code works, but you're wrong. Yeah, we can't really trust that we know how this code works. It's big enough and complex enough that I don't think we can. So if I were testing this manually, probably what I would do is come over here and do the keyboard and mouse navigation and click the buttons. And that would probably be it. Oh, and then there's this whole multi-page introduction as well. Whew, that's even more complicated. Yeah, maybe what we do is we test this multi-page, run this multi-page example. And normally what I would do is test it manually and ensure that it was working like it was supposed to. But of course, what we want to do here is we want to not have to test it manually. Although sometimes when I'm adding tests to legacy code, I will just test something manually. But it's better if we don't. So rather than using something like Karma and doing unit tests, which I really don't think we can do just yet, I think what I'd like to do is use Casper.js to actually, load this example, click around on it, do the clicks and the button presses. And then the pinning part is we need to make sure that that we don't break the way the DOM works. So we'll write the test and we'll save off the way it works before we make any changes. Like we'll actually store the state of the DOM after each step. And let's say after a half-second delay after each step, because there's this animation. And in subsequent tests, we will confirm that the DOM is in exactly that state after each step. So this is what makes a pinning test, is we're going to write some code to manipulate this page programmatically using Casper.js, and we will save the DOM in a file, actually just save it out or just dump it to text or something like that, and then compare that doesn't change. That's what I'm thinking we'll do here. Okay, so that's the strategy. I don't know if it's a good strategy. We'll find out. So our strategy is to write a pinning test that runs multi-page example, compares to known good DOM after every step. And that is going to be assuming that we get the animations right. So we might want to write test around the animations, but that is a lot of work. So we might just avoid that part of the code or test it manually. And I guess before we write that pinning test, we need to get the code to build, and we also need to set up some basic automation. Okay, that brings us to the end of the first part. This is a huge topic, so we will continue this next month. What we'll do next month is we will work on getting this code under control and getting pinning tests in place. And then in the following episode, in part 3, we'll look at actually doing the refactoring and putting in unit tests. To review what we've done here, we start out with reflective design. We analyzed intro.js and sort of figure out what the important parts of it were. We wrote down the different methods and divided them up into their purpose. In a larger project, we would have done this on a file basis, not a method basis. And then once we had a good understanding of how everything fit together, we decided what our goal was going to be, what we wanted to refactor, what we wanted to potentially change, and then we came up with our test strategy. We decided that we wanted to get the code under control by getting the code to build locally, setting up some automation, and then writing a pinning test that is going to run the multi-page example and compare it to a known good DOM. That is what we're going to do next time. Thanks very much for joining me, everyone, and I will catch you next time.